Hey guys, tonight we stand under a sky that looks immediate and intimate, as if the stars have just switched themselves on for your benefit, like tiny, considerate lamps hung above the roofline. But the strange, beautiful truth is that nothing up there is happening right now in the way your eyes insist it is. The light arriving tonight has been traveling for years, decades, sometimes far longer, crossing cold distance with the patience of something that has never once been in a hurry. Before you get cozy, take a moment to like the video and subscribe, but only if you genuinely enjoy spending time here with me. And wherever you're listening from, post your location and your local time down in the comments, because there is something quietly lovely about knowing how many different nights are overlapping here together. Let the world slow down for a moment. Let the fan murmur softly nearby, and let's slip into tonight's journey together. You look up, and the first calming fact settles over you. Starlight is old. Not metaphorically old, but literally old, with an age you can count in years of travel. When you see Sirius, one of the brightest stars in the night sky, you're seeing light that left it about 8.5 years ago. The star did not flash at you in real time. It mailed you a postcard, and the postal service was the vacuum of space, which, to be fair, is not known for urgency. That delay is not a flaw. It is the whole magic trick. You spend so much of life surrounded by things that demand immediate attention. Notifications, headlines, people expecting a reply in under 4 minutes, as if silence for 6 is a declaration of war. But the sky does not work like that. It gives you an archive. Every point of light is a tiny act of delayed presence. A signal sent long ago and only just now arriving at the shore of your attention. That means the night sky is less like a screen and more like a museum, except darker and with fewer children sprinting past the signs. You're not simply looking outward. You're looking backward. You're seeing stars as they were. In a very real sense, the universe lets you watch history glow. Even the moon is not quite current. Moonlight takes a little over a second to reach you. The sun is older still, its light taking about 8 minutes to arrive. If the sun somehow vanished, which would admittedly ruin the mood, Earth would keep basking in sunshine for those last 8 minutes, blissfully unaware. Reality itself has a softness to it, a built-in delay, as if the cosmos gently insists that nothing arrives all at once. Move farther out and the delay grows. Mars sends its light in minutes. Jupiter takes longer. Saturn longer still. By the time you reach the stars, those minutes become years, and the years become dozens, hundreds, thousands. Some stars visible to the naked eye are so distant that the light entering your eyes tonight started traveling before whole chapters of human history unfolded below. There are stars whose visible glow began its journey when people on Earth had different maps and different worries, still paying taxes, because apparently the universe permits many mysteries but not administrative peace. This is one of the gentlest cosmic mysteries. Your eyes do not see the universe as it is. They see the universe as it was, layered in delays. The farther you look, the older the story. You are never receiving the night all at once. You are receiving a collage of different times, stitched together by distance and light. And light itself is wonderfully strange. It is the fastest thing the universe allows. Nothing with information outruns it. It races through the vacuum at about 300,000 kilometers every second, and even at that absurd speed, space is so enormous that light still needs years to cross the gulfs between stars. So large that even light, the ultimate overachiever, has to commit to the journey. A light year, despite sounding like something a science teacher says right before writing a quiz, is simply the distance light travels in 1 year. Nearly 10 trillion kilometers. When you hear that a star is 50 light years away, that means the light reaching you tonight left when 50 years of Earth life still had not happened. If a star sits 1,000 light years away, you're seeing a 1,000-year-old message. The sky is never merely decorative. It is a slow-delivered conversation between deep time and your small, very awake human moment. Some of the stars you see may even be gone already. Their light can continue traveling long after the star itself has changed or died, which sounds dramatic. But in the night, it feels almost tender. A vanished star can still send beauty forward. It can still appear, still shine, still keep its appointment with your eyes. For a while, at least, the universe allows an afterimage to exist with perfect dignity. Not fake, not false, just delayed. This also means that when astronomers point telescopes deeper into the universe, they're not just magnifying distance. They are peering into earlier eras. A telescope is, in a way, a time machine built from mirrors and patience. The deeper it looks, the farther back it sees. Ancient light arrives here anyway, slipping through air, crossing your window or the open night, and landing softly in your eyes. That is such an intimate ending for such a long voyage. There is comfort in that. A photon can spend centuries traveling without interruption, only to complete its grand adventure by meeting a sleepy person in pajamas staring upward and thinking, wow. There is another comfort in delayed starlight. The sky teaches you that distance is not emptiness. Between the star and your eyes is an enormous stretch of seeming nothing. But that nothing is not meaningless. It is the road. The dark is not a failure of connection. It is the space that allows connection to happen. Light crosses it faithfully, quietly, continuously. That can make the night feel less lonely. Every star overhead is evidence that something can endure the crossing. Something can leave home and still arrive. Something can travel through cold silence and still carry warmth by the time it reaches you. So you keep looking. Maybe you pick out Orion or the Big Dipper or one bright star above a rooftop edge. Maybe clouds move through and erase half the view, which feels rude, but even that does not really break the spell. The light is still coming. It has already survived worse than weather. The stars are in no panic. They are simply shining, and their shining reaches you when it reaches you. You can let that pace enter your breathing. You can let the idea settle that not everything meaningful is immediate. Some of the most beautiful things in existence take a very long time to arrive. Some messages are worth the wait, simply because they cross so much to be seen at all. The sky is proof of that every clear night. A grand ceiling of delayed brightness. A patient record of light still finding its way. And maybe the most relaxing part of all is this. You do not have to solve the mystery to enjoy it. You only need to notice that the heavens above you are not present tense. They are memory made visible. A soft parade of old light, arriving without fuss, asking almost nothing of you except that you look up for a moment and receive it. So the next time a star catches your eye, you can greet it for what it really is. Not a spark of now, but a traveler from then. A small, shining delay. A piece of the past placed carefully in your evening. The stars keep sending their old light. You keep receiving it. And somewhere between the sending and the receiving, between the ancient source and your quiet room, the universe becomes less like a machine and more like a long, slow breath. You keep that feeling of old light with you as the sky grows deeper, because the next mystery is even quieter. It does not shine at all. It does not glow blue or red or silver. It does not send you a postcard from 8.5 years ago like Sirius showing off its commitment to delayed communication. It simply seems to be there through its effects, like an invisible stagehand moving scenery in the dark while the actors get all the applause. This is dark matter, one of the most soothingly rude discoveries in science, because it forced astronomers to admit that most of the universe is apparently made of something they cannot directly see. You have to admire the nerve of reality. Humanity invents telescopes, mathematics, observatories, giant instruments balanced on mountaintops, and the universe responds by saying, "Yes, adorable effort. Now, please explain the missing mass." The mystery began to sharpen when astronomers studied how galaxies move. A galaxy is not a static ornament pinned in space. It is a massive spinning city of stars, gas, dust, and gravity, all turning together. You might expect the stars near the crowded center to move differently from the stars farther out, just as planets in the solar system orbit with speeds that depend on their distance from the sun. And yet, when astronomers measured how fast stars were moving in galaxies, especially out toward the edges, something strange appeared. Those outer stars were moving much too fast. Too fast. That is, if the galaxy only contained the matter you could actually see. By all normal expectations, the visible material in a galaxy should not create enough gravity to keep those speedy outer stars from wandering off into the dark like guests leaving a party the moment the snacks run out. But they stayed. The galaxies held together. Their stars kept orbiting as if some extra gravity were present, some hidden mass extending beyond the bright spiral arms. And so science arrived at one of its most elegant confessions. Something invisible seems to be helping. That invisible something was called dark matter, not because it is evil or moody or listening to obscure music in a turtleneck, but because it does not interact with light in the ordinary way. It neither emits nor reflects nor blocks light like familiar matter does. You cannot look at it directly. You infer it from what it does. You notice the curve of motion. You watch the way galaxies rotate. You observe how gravity behaves on enormous scales, and you realize the visible universe is only part of the furniture. There is something almost relaxing about that. You already live surrounded by invisible forces. Air wraps around you without asking for attention. Gravity holds your body to Earth with complete professionalism and no need for applause. Radio waves pass through walls, carrying songs, news, awkward advertisements, and probably one deeply specific coupon you never requested. The world is full of unseen structures. Dark matter is just the cosmos taking that principle and scaling it up to an absurdly grand level. Imagine a galaxy like a glowing pinwheel. The stars you can see are only the lit windows. Around and through that shining structure seems to be a vast halo of dark matter, stretching well beyond the visible edges. The galaxy is not merely a bright island in darkness. It appears to be embedded in an enormous, invisible framework, like a chandelier hanging from a ceiling you cannot see. That hidden framework matters because gravity is democratic. It does not care whether you are glowing beautifully for a telescope or remaining stubbornly invisible out in the dark. Mass is mass, and gravity responds. So if a galaxy behaves as though it contains far more mass than meets the eye, the simplest explanation is that it does. Dark matter also leaves its fingerprints in even grander ways. Entire clusters of galaxies, those giant gatherings where hundreds or even thousands of galaxies share space, also seem to contain far more mass than visible matter can explain. The galaxies inside them move too quickly. The hot gas between them behaves as though stronger gravity is present. Once again, something unseen appears to be quietly carrying weight. And then there is gravitational lensing, which sounds like a gentle eyewear brand for planets, but is actually one of the loveliest effects in astronomy. Massive objects bend the path of light. Gravity curves space, and light follows that curve. So when astronomers observe light from very distant galaxies being distorted, stretched, or multiplied by something massive in front of them, they can map where the mass must be, even if much of it is invisible. In a sense, dark matter can be outlined by the way it bends the ancient light we talked about earlier. Even the invisible cannot help leaving traces when gravity gets involved. This means scientists can create maps of dark matter's distribution by studying how background light is warped. That is such a peaceful idea. The unseen becomes visible only through its influence, like wind traced by tall grass moving, or a person you love recognized by the way a room feels different after they leave. You may be tempted to think dark matter is simply ordinary stuff hiding in the dark. Maybe dim stars, cold gas, dead objects, cosmic clutter tucked where telescopes struggle to see. That idea was considered. It would have been convenient. Sadly, the universe did not feel like being convenient. Observation suggests there is far too much hidden gravity for normal matter alone to explain. Dark matter seems to be something else entirely, some form of matter we have not yet directly identified. Scientists have proposed various candidates. Weakly interacting massive particles had a long season of fame. Axions, tiny hypothetical particles, have their own devoted following. There are other possibilities too, each with elegant math, elaborate detectors, and the hopeful energy of people listening very carefully for footsteps in the dark. So far, no single candidate has stepped forward and said, "Hello, I have been the answer all along, sorry for the delay." Still, the evidence for dark matter's effects is strong enough that the mystery remains central, not fringe, not decorative, but foundational. It appears to shape how galaxies formed in the early universe. Without dark matter, the large-scale structure of the cosmos would likely look very different. It acts almost like scaffolding. Ordinary matter, the kind that forms stars, planets, coffee mugs, suspicious leftovers, and you, appears to have gathered in the gravitational wells dark matter helped create. That image makes the universe feel surprisingly cared for. Not in a sentimental way, but in an architectural one. The visible cosmos may be built inside an invisible framework. The stars are dazzling, yes, but they may owe their arrangement to something that never asked to be seen. There is a soft humility in that. The grand glow of galaxies may depend on a silent partner. And silent really is the right word. Dark matter does not seem to clump up into glowing stars. It does not crash into itself and heat up in ways that produce brilliant clouds. It mostly reveals itself through gravity, which is perhaps the most low-drama method available to a cosmic substance. No flashing entrance, no triumphant soundtrack, just a persistent tug on the motions of things. That gentleness makes it easier to imagine. You can picture the universe layered like this. Visible matter sparkling here and there, galaxies turning like slow lanterns, while around them and through them stretches an unseen sea of mass, calm and immense. A hidden presence not because it is trying to deceive you, but because the universe contains modes of being that your eyes were never designed to register. Human vision, after all, is a very local tool, useful for stairs, soup, road signs, and deciding whether that plant near the window is still alive or merely committed to denial. But the cosmos is under no obligation to limit itself to what a primate retina finds convenient. Dark matter is one of the great reminders that reality vastly exceeds perception. There's another reason this mystery can feel comforting rather than frustrating. Dark matter tells you that not understanding everything is not the same as knowing nothing. Scientists did not shrug and give up when galaxies behaved strangely. They measured more carefully. They compared observations. They built models. They revised ideas. They let the evidence pull them somewhere unexpected. That is a beautiful way to meet the unknown. Not with panic, but with patience. And patience feels like the right emotional temperature for the universe. The same cosmos that sends you starlight years late also hides enormous portions of its structure behind invisibility. It is not a place of instant answers. It is a place of hints, footprints, distortions, motions, gentle clues written into the turning of galaxies. It invites you to notice what does not quite add up and to rest for a moment in the fact that mystery is not a crack in reality. Mystery is part of reality's design. So you imagine those galaxies again, spinning in the deep. Their visible stars wheel around their centers, elegant and bright. Beyond the glow lies more than darkness. There's weight there, a vast, invisible halo, keeping the structure together, shaping motion, helping beauty hold its form. The cosmos is fuller than it looks. The night is supported by hidden things. And maybe that feels familiar too. So much of what sustains a life is not glamorous. Quiet loyalties, unseen effort, the invisible architecture of habit, memory, and care. Dark matter is not a sentimental lesson, but it does whisper one anyway. the hidden is not always empty. Sometimes the hidden is what keeps everything from flying apart. That hidden architecture leads you naturally toward another object famous for attracting drama it frankly does not need. Black holes have suffered terribly at the hands of movie scripts. If popular culture had its way, every black hole would spend its free time roaring like a cosmic vacuum cleaner, shredding spaceships on schedule, and generally behaving like the universe woke up and chose violence. The truth is much calmer, much stranger, and somehow much more beautiful. A black hole is not a hole in the ordinary sense. It is not a tunnel punched through space like some giant celestial drain. It is a region where matter has been compressed so densely that gravity becomes overwhelming. The key boundary around it is called the event horizon, and this is where things get wonderfully eerie. Cross that boundary, and escape becomes impossible, not because some monster reaches out and grabs you, but because space itself is curved in such a way that all possible paths lead inward. That is one of the first relaxing corrections. A black hole is not sitting out there, sucking in everything nearby like a deranged blender with trust issues. If our sun were somehow replaced by a black hole of the exact same mass, which would be a fairly inconvenient morning, Earth would not suddenly get slurped into oblivion. It would keep orbiting much as it does now, because gravity at a distance depends on mass, not on whether that mass is a star or a black hole. We would, admittedly, freeze in darkness, which is not ideal for the tomatoes, but our orbit would not instantly unravel. So black holes are not cosmic hunters lunging across the galaxy for unsuspecting planets. They're more like extremely intense gravitational wells. Get close enough, and they matter very much. Stay far enough away, and they behave with surprising restraint, which is not the reputation they usually get, but then neither do introverts at office parties. Some black holes form when massive stars reach the ends of their lives. A star spends millions of years fusing elements in its core, pushing outward with radiation while gravity pulls inward. It is an elegant stalemate, but when the fuel runs out, gravity can finally win. The core collapses. In the most massive cases, the collapse continues beyond neutron star territory and forms a black hole. What remains is not an angry void, but the compressed aftermath of a star's final surrender to gravity. There are also much bigger black holes, the supermassive kind, sitting in the centers of galaxies like quiet monarchs no one fully understands. These can contain millions or even billions of times the mass of the Sun. The Milky Way has one too, called Sagittarius A star, and it resides far away at our galactic center, not doing anything personally to you, which is considerate. Stars near it orbit rapidly, revealing its enormous mass. It is or not because astronomers enjoy naming alarming objects, but because the evidence points to a massive, compact thing occupying the galactic heart. And yet even these giants are mostly surrounded by vast space. The universe is not crowded. Black holes are dramatic in concept, but they are also isolated, embedded in huge distances. That helps soften them. They're less like traps laid in a hallway, and more like remote mountain lakes that happen to have terrifyingly deep centers. The event horizon deserves a little more attention because it is one of the most delicate boundaries in science. From far away, it is just a surface beyond which no light returns. That is why black holes look black. Light emitted from inside cannot escape to tell you what is happening. But this does not mean the event horizon is a physical shell you would smack into like a wall in a video game. In many cases, if you crossed it, you might not notice the boundary itself in that instant, which is both elegant and unsettling. The universe once again proving that the most serious transitions often come without a sound. Time begins to behave strangely near black holes too, and this is where the mystery becomes less frightening and more dreamlike. According to relativity, gravity affects time. The stronger the gravity, the slower time passes relative to a distant observer. Near a black hole, this effect becomes extreme. If you watch someone fall toward the event horizon from far away, their motion would appear to slow. Their light would stretch to redder wavelengths, dimming and fading, as though time itself were becoming syrupy around them. From their own perspective, things would feel different. They would continue inward, but from yours, far away, they would seem to hover and fade. The black hole turns time into a strange theater where different viewers do not agree on the pacing of the same scene. This is one of those facts that makes your normal schedule feel deeply provincial. You worry about being 5 minutes late, while gravity casually reshapes duration itself. That slowing of time is not just a black hole curiosity. It is a clue that black holes sit at the crossroads of major ideas in physics. Gravity, space, time, energy, information all begin to press against each other there. The mathematics grows intense. The concepts get slippery, but the feeling can stay calm. A black hole is a place where the universe reveals that space and time are not stiff background props. They bend, they stretch, they respond. Then there's the matter of what lies at the center. According to general relativity, if collapse continues without interruption, matter is driven into a singularity, a point where density becomes effectively infinite and the known laws of physics stop behaving sensibly. Scientists do not take that as a satisfying final answer, so much as a sign that current theories are incomplete. Infinity in physics often means, congratulations, you have reached the edge of what this equation can gracefully handle. It is less a solved ending than a note saying, further understanding required. And that is oddly comforting. Even black holes, those icons of cosmic extremity, are not fully understood. The universe keeps a private room in the house, and black holes seem to stand outside it with the key half visible. There is another mystery woven into them, one that has charmed and annoyed physicists for decades. Black holes do not seem entirely black after all. Quantum theory suggests they can emit a faint glow known as Hawking radiation. This arises from the strange rules of quantum fields near the event horizon. Over incredibly long timescales, a black hole could lose energy this way and slowly evaporate. So the darkest objects in the universe may not be perfectly dark. Even here, there's a whisper. That whisper leads to the famous information puzzle. If something falls into a black hole, what happens to the information describing it? Quantum theory dislikes the idea that information can simply vanish forever. General relativity, meanwhile, is not exactly handing out reassuring pamphlets at the event horizon. So physicists have spent many years trying to reconcile these views. Perhaps the information is somehow encoded on the horizon. Perhaps it emerges in subtle ways. Perhaps our deepest theories still need a better marriage counselor. Either way, black holes remain less like dead ends and more like stern exam questions written by the universe. And still, for all the abstraction, black holes can be observed. Not directly in the sense of seeing inside them, but through their effects. Matter spiraling toward a black hole can heat up and glow brilliantly in an accretion disk, releasing enormous energy. Some black holes launch jets that shoot particles across vast distances. In recent years, humanity even captured images of black hole shadows, those dark central silhouettes ringed by glowing material. They looked almost exactly how the imagination wanted them to look: calm, circular, severe like cosmic ink stains. Gravitational waves added another layer of wonder. When black holes collide, they ripple space-time itself. These ripples can pass through Earth, stretching and compressing space by absurdly tiny amounts, and instruments can detect them. Think about that for a moment. Two black holes merge billions of light years away, and the fabric of reality shivers just enough for delicate machines here to notice. The universe is quiet, but it is not mute. Maybe that is why black holes feel less frightening when you sit with them longer. They're not tantrums in space. They're consequences. Geometry under pressure. Gravity carried to its elegant extreme. They bend time, hide their centers, preserve their silence, and still leave clues for anyone patient enough to listen. So you picture one now, not as a threat lunging through the dark, but as a still point. A place where starlight can circle, where clocks disagree, where matter crosses a line and vanishes from ordinary view. Around it, perhaps a disk of hot gas glows like a slow golden whirlpool. Beyond it, stars continue their orbits. The galaxy does not scream. Space does not panic. The black hole simply exists, severe and composed, holding one of the universe's deepest questions inside a boundary made of no material at all. And that may be the gentlest truth about it. Even the most intimidating mystery in the night sky is, at heart, quiet. Black holes are not chaos dressed in darkness. They're order taken somewhere your intuition cannot quite follow. They are what happens when gravity becomes poetry and refuses to explain itself in simpler terms. The quiet around black holes makes it easier to notice another kind of quiet, one spread everywhere, so wide and constant that it can almost disappear into the background of your thoughts. Space is often described as empty, and to be fair, it does look committed to the bit. Vast black reaches, long distances between stars, room enough for galaxies to spin without bumping elbows. But the more carefully you listen to the universe, the less empty it seems. Not crowded, not noisy, not cluttered like a kitchen drawer full of mystery cables, but gently inhabited by leftovers, traces, and whispers that have never fully gone away. One of the softest and strangest of those whispers surrounds you right now. It is called the cosmic microwave background, though that name sounds less like an ancient relic of creation and more like a setting on an appliance you regret buying. In reality, it is the faint afterglow of the early universe. Light released when the cosmos was very young and hot and dense, and then stretched over billions of years as space expanded. It fills all of space. It comes from every direction. It is not dramatic. It is not flashy. It is, in the most comforting possible way, a low and persistent murmur left over from the beginning. You can imagine the early universe not as a starry black emptiness, but as a bright, dense, energetic fog. In its infancy, matter and radiation were packed together in a kind of glowing plasma. Light could not travel freely for long because it kept scattering off charged particles, bouncing around like a person trying to leave a crowded room after everyone suddenly remembers one more thing they meant to say. The universe was opaque then, not because it was dark, but because it was too busy. As the cosmos expanded, it cooled. Eventually, it reached a point where electrons and atomic nuclei could combine into neutral atoms. Suddenly, light was able to move freely without being constantly deflected. The fog cleared. Radiation streamed outward, and that ancient light has been traveling ever since. That ancient light is still here, not visible to your eyes, because its wavelengths have been stretched by the expansion of space into the microwave part of the spectrum, but here nonetheless, surrounding you, passing through the walls, through the air, through the night, a faint relic of a much younger universe. The darkness above your roof is not truly blank. It is gently illuminated by an afterimage from nearly the beginning of everything you know. There is something deeply soothing about that. The universe did not erupt once and then forget itself. It kept a receipt. It left a thermal signature. It preserved a soft record of its youth, and that record remains available to anyone patient enough to build the tools to detect it. When scientists first found this background signal, it was one of those wonderful moments where reality casually confirms an idea with the confidence of someone handing back a set of keys. A faint microwave hiss seemed to come from every direction. No matter where the instrument pointed, the signal remained. It was not city interference, not bird droppings, not local contamination. Though to be fair, scientists do often have to rule out deeply humiliating possibilities before reaching glory. It was the cosmos itself, whispering evenly from all sides. That evenness matters. The cosmic microwave background is astonishingly uniform across the sky, almost the same temperature everywhere, with only tiny variations. Tiny, minute fluctuations. Yet those tiny differences were enough to matter enormously. They marked slight density differences in the early universe, places where matter was a little more concentrated than elsewhere. Over immense time, gravity amplified those small irregularities. They helped give rise to stars, galaxies, clusters, structure. So the great architecture of the visible universe may have grown from extremely subtle ripples in an ancient glow. That is such a gentle image. Giant galaxies, dark matter halos, black holes, all the grand things we've been talking about, emerging from faint unevenness in a warm early afterglow. Magnificence born not from chaos shouted aloud, but from tiny differences patiently expanded across time. And if you could somehow translate part of that early universe into sound, it would not be silent at all. Before the cosmos became transparent, pressure waves rippled through that hot plasma. In a sense, the early universe rang, not sound traveling through vacuum as it would fail to do in empty space, but waves moving through the dense medium that existed then. A kind of cosmic acoustics. The young universe had rhythm, oscillation, compression, release. That means the structures you see later in galaxies and background radiation preserve the memory of ancient vibrations. The universe once had something like a tone, a slow, vast music of density waves moving through fire and light. You would not have heard it with human ears, of course. The frequencies and conditions were wildly different, but the idea itself is calming. Before stars, before planets, before anyone worried about deadlines or whether that text sounded too blunt, the universe was already humming. You might like that phrase, the hum of empty space, because it captures the trick so well. Space now is mostly vacuum. Ordinary sound, the kind your ears know, needs a medium like air or water to travel. So if you were floating between stars, no thunder would roll past you. No whisper would drift over your shoulder. And yet space still holds information. It still carries radiation. It still contains fields, particles, background glow, gravitational waves passing almost imperceptibly through it. Quiet is not nothing. Quiet is a different kind of fullness. That distinction matters because emptiness can sound lonely if you picture it badly. But cosmic emptiness is not a barren blank. It is a stage with subtle lighting. It is threaded with invisible activity. There are magnetic fields in places, streams of particles from stars, interstellar gas, so diffuse it hardly seems to count, yet it does. There are neutrinos passing through matter with barely any interaction at all, like the universe's shyest visitors. There is the microwave background, still present. There may even be the soft fizz of quantum fields, where what seems empty is not absolutely devoid of fluctuation. The vacuum is not dead. It is alert in its own minimal, elegant way, and that can make the night feel richer. The darkness between stars is not merely the absence of stars. It is an environment. Sparse, yes. Cold, yes. But not featureless. Space contains old light, and the old light carries memory. It is one of the reasons astronomers treat the sky not just as scenery, but as evidence. The universe is full of records if you know how to read them. The cosmic microwave background is one of the oldest of those records you can meaningfully observe. Older than any star you see with your eyes. Older than galaxies in their mature forms. It comes from a time when the universe was only about 380,000 years old, which in cosmic terms is practically infancy. A tiny baby universe, still warm, still simple enough to leave a clean background signal before later structures complicated the view. And yet even that background is not perfectly smooth. Those tiny blotches in temperature, warmer here, cooler there by minuscule amounts, became a treasure map. They tell scientists about the universe's composition, geometry, age, and growth. The background whisper contains data so deep that by reading it, humanity learned extraordinary things about the cosmos as a whole. It is as if the universe, while still very young, left behind a note saying, in case anyone intelligent appears later, here are some useful clues. There's an intimacy in that too. The relic glow from the early universe reaches not just giant observatories, but the planet you are on, the room you are in, the body lying still while your mind wanders outward. The afterglow of creation passes through your world all the time. You are inside the whisper, not outside it. And perhaps that is the most restful part of this mystery. You're not peering into a universe that is wholly distant from you. You are immersed in it. The ancient signal is not somewhere else. It is everywhere. Even now, as you breathe and listen and imagine that old plasma cooling into transparency, the background radiation remains spread across the cosmos like the last warmth left in a vast room after the fire is burned down. It has cooled to just a few degrees above absolute zero now, stretched thinner and softer by expansion. But it remains astonishingly detectable, astonishingly faithful. The universe has changed beyond recognition since that glow was released. Stars ignited, galaxies assembled, planets formed, creatures evolved. You arrived, and still the whisper continues. Not louder, not more urgent, simply present. That constancy can make you feel very small, of course, but also very held. Reality is enormous. Yes, and old beyond ordinary comprehension, but is not mute or inaccessible. It leaves traces. It shares leftovers. It lets you discover the hum behind the silence. And once you notice that, the old phrase, empty space, begins to sound a little lazy. Space is not empty in the way an abandoned room is empty. It is empty in the way a sleeping house is quiet, with currents in the walls, warmth in the floorboards, pipes gently ticking, memory held in every corner. So the dark sky above you is not only a museum of delayed starlight, and not only a stage supported by invisible dark matter, and not only the home of black holes keeping their severe little secrets. It is also bathed in a faint relic glow, the oldest light most people never think about, the afterbreath of a young universe, still somehow present after all this time. And that means the silence of space is not total silence at all. It is layered silence, textured silence, a hush with a history. The kind of hush that, when you lean close enough in thought, turns out to be softly singing. That layered hush becomes even more beautiful when you realize some of the most radiant places in the cosmos are not stars at all, but clouds. Vast, delicate, impossible-looking clouds made of gas and dust, spread across light years, glowing, dimming, curling, and folding in on themselves with the lazy grandeur of something that has never once been asked to hurry. Nebulas are among the universe's loveliest deceptions because they look soft and decorative, like celestial watercolor spilled across black velvet, when in fact they are busy places. Messy places, birthplaces. The cosmos, it turns out, does not arrange its beginnings in neat little drawers. And honestly, that is reassuring. A nebula is, in the broadest sense, a cloud in space. Sometimes it is the leftover material of dying stars. Sometimes it is a region where new stars are forming. Sometimes it is both, because the universe enjoys recycling with a level of commitment that would make your local council emotional. These clouds are made mostly of hydrogen, with helium and traces of heavier elements, plus dust grains so tiny they sound insignificant until you remember that entire solar systems can eventually come from this stuff. A little humility is good for the species. The word dust sounds unimpressive. Dust is what gathers on shelves and makes people pretend they were just about to clean. Cosmic dust, though, is not the same as the neglected top of a bookshelf. These particles can be made of silicates, carbon-rich compounds, ices, and bits of heavier elements forged in stars. Tiny grains, yes, but profoundly important ones. They absorb and scatter light. They cool clouds. They help shape chemistry. They gather, stick, shade, and participate. Dust is one of the secret artisans of the universe. That means the bright sky is not only about what shines, but also about what hides. Some nebulas glow because nearby stars flood them with radiation, exciting the gas so that it emits light. These are emission nebulas, often rich in reds, because hydrogen, being the universe's favorite minimalist, has a particular talent for glowing in that color under the right conditions. Other nebulas reflect the light of nearby stars, scattering blue wavelengths more effectively, which gives them a pale bluish appearance. Reflection nebulas are less like lamps and more like moonlit mist. And then there are dark nebulas, dense clouds that block light from objects behind them, appearing as inky shapes cut into brighter star fields. The sky's own silhouettes. The cosmos proving once again that absence can be just as expressive as brilliance. If you have ever seen images of the Orion Nebula, the Eagle Nebula, the Lagoon Nebula, the Carina Nebula, you already know how absurdly beautiful these places appear. Columns, filaments, knots, arcs, caverns of light. They look painted, staged, curated for dramatic effect. But those familiar colors are often enhanced or translated from wavelengths your eyes cannot naturally see in full detail. Which is not cheating. It is interpretation. It is the scientific equivalent of turning up the lamp so you can notice what was always there. Nebulas do have structure and color, just not always in the exact bold way posters and desktop wallpapers imply. Still, the truth is no less magical. These are real regions, real clouds, real places where matter gathers and changes state over immense time. And hidden inside, many of them are stars being born. That phrase sounds poetic because it is annoyingly accurate. Inside cold, dense regions of molecular clouds, gravity slowly begins to gather matter into clumps. Those clumps grow denser. Pressure rises. Material falls inward. The cloud collapses not all at once, but in pockets, in fragments, in a slow gathering of possibility. Over time, a protostar forms, still shrouded in gas and dust, not yet fully ignited, but on its way. Surrounding it may be a rotating disk of leftover material, the kind that can eventually build planets, moons, asteroids, comets, and future arguments about whose telescope app is more accurate. There is something deeply restful about the pace of all this. Star birth is not an explosion of urgency. It is not the universe slamming a big red button labeled Create Sun. It is gradual, hidden, protected by dust. A long inward fall before the first true light. The protostar warms as gravity compresses it, and when the core becomes hot and dense enough for nuclear fusion to begin, a star is born in the proper sense, joining the great long conversation of starlight that later reaches eyes like yours across impossible distance. So when you look at a nebula, you're not only seeing a cloud. You may be seeing a nursery, a concealed workshop, a region where future stars are assembling behind curtains of dust thick enough to hide them from ordinary view. That is why astronomers often use infrared observations to peer into these places. Visible light can be blocked by dust, but infrared can pass through more effectively, revealing the warm young objects embedded inside. The universe hides its beginnings, but not perfectly. It lets you peek if you ask in the right wavelength. That feels consistent with everything else the night has shown you so far. Old light arriving late. Dark matter revealing itself only through gravity. Black holes holding their secrets behind an event horizon. The cosmic microwave background whispering from all directions. Again and again, the universe says the same thing in different accents. The most important realities are not always obvious at first glance. Nebulas make that lesson feel tender rather than severe, because for all their scale, they are also about shelter. Dust, which sounds like a nuisance until it starts manufacturing worlds, acts like a veil. It shields young stars and molecules from harsh radiation. Some of the most famous structures in nebulas are the towering columns of gas and dust, like the so-called pillars of creation. The name is wonderfully dramatic, and for once the drama is deserved. These immense columns are shaped by radiation from nearby hot stars, which slowly eats away at the cloud, leaving behind denser structures that resist erosion longer. Within those structures, star formation can continue. So even the beautiful shapes themselves are temporary, sculpted by light, worn away by time, and carrying hidden embryos of future stars inside them. Temporary. That is important. Nebulas are not eternal decorations pinned onto the galaxy. They change. They disperse. They collapse. They are moments in a larger cycle. Stars form from clouds, live out their long, luminous lives, and then return material to space through winds or explosive endings. That material enriches the next generation of clouds with heavier elements. The carbon in living things, the oxygen you breathe, the silicon in rocks, the iron in blood, all these elements were forged in stars and returned to space before becoming part of later worlds. Nebulas are part of that circulation, not static scenery, but passages in a grand exchange. And because they are so large and diffuse, a nebula that looks dense in a photograph is often still far emptier than any vacuum humans can create in a laboratory. If you floated inside one, you would not feel smothered in colored fog. You would barely notice anything physically around you at human scale. This is one of those delightful cosmic betrayals. The clouds are real, but their thickness is spread over such enormous distances that the density remains extraordinarily low. Beauty by accumulation, structure by patience. That makes them even more dreamlike. A place can be full and thin at once, vast and subtle, brilliant from afar, nearly nothing in the hand. Which, to be fair, is also how some people describe decorative throw pillows, but the nebula wins on grandeur. You keep following the thought outward. Somewhere in one of these dusty regions, a star begins to ignite. Around it, a disk turns. In that disk, grains collide and cling. Pebbles form. Bodies gather. Worlds begin. The whole process takes millions of years, with no audience, no applause, no little ribbon-cutting ceremony. Just gravity, dust, chemistry, and time. The universe making homes from leftovers. And perhaps that is why nebulas feel so comforting. They show you that beginnings are allowed to be unclear, allowed to be hidden, allowed to be messy, slow, and half obscured behind dust. Not every creation starts with clean lines and certainty. Some start inside cold clouds. Some need darkness to gather themselves. Some need a veil before they can shine. So the next time you imagine the sky, you can imagine these enormous nurseries suspended within it. Not only stars already blazing with old light, but clouds still busy preparing the next generation. Great folds of gas lit from within, dark lanes stitched through brighter regions, dust grains drifting like microscopic seeds through the black. The hum of empty space is not empty here. It is full of assembly. The universe, even in silence, is still building. From those dusty nurseries, where stars gather themselves behind veils and young worlds begin as grains in a spinning disk, it feels natural to keep following one of those worlds farther than it was ever meant to go. Not every planet stays politely tethered to a sun. Not every world keeps its assigned seat in the cosmic arrangement. Some are nudged, some are scattered, some are outright flung into the dark by the complicated gravitational politics of their own home systems. And once they leave, they do something both eerie and oddly peaceful. They continue. These are rogue planets, also called free-floating planets, and they're among the most quietly mesmerizing objects in space. No sonrisa. No parent star warming one side and leaving the other tonight. No bright annual loop through familiar seasons. Just a world, entire and intact, traveling through interstellar darkness alone. It sounds lonely at first, because humans are very attached to lamps. We see a planet without a star and immediately imagine cosmic abandonment, as though the universe has staged some tragic breakup, and now the planet is wandering the galaxy, listening to songs about healing. But the reality is gentler than that. A rogue planet is not broken simply because it is solitary. It is still a world. It still has mass, geology, perhaps an atmosphere, perhaps ice, perhaps hidden warmth. It still moves through the galaxy under the same patient laws that govern everything else. It has simply left the bright neighborhoods. Some rogue planets may have formed in the ordinary way, in disks around young stars, only to be ejected later. This can happen when giant planets shift positions, when multiple massive bodies tug each other into unstable arrangements, or when passing stars disturb a young system enough to fling smaller members outward. Planetary systems, for all their majestic diagrams, are not always calm. In their youth, they can resemble a formal dinner party where one guest abruptly flips the table and everyone pretends this is part of the entertainment. If a massive planet migrates inward or outward through a young system, gravitational interactions can toss other worlds into strange orbits. Some may collide. Some may spiral inward toward the star. Some may be hurled away entirely, achieving escape velocity and becoming nomads. A planet can spend millions of years assembling in a warm disk of gas and dust, only to be launched into deep space like a suitcase flung from a moving train. The universe is elegant, yes, but also fully capable of producing family dynamics. There's another possibility too. Some free-floating objects may form more like stars through the direct collapse of gas clouds, but simply never gather enough mass to ignite fusion. They begin in darkness and remain there, too large to be ordinary planets in one sense, too small to be stars, inhabiting that in-between territory the cosmos seems to adore. Categories comfort humans more than they comfort reality. What makes rogue planets so calming to imagine is the quality of their darkness, not the sharp night of Earth, where moonlight, air glow, city haze, and the memory of day still linger. Not even the black around a black hole, where warp time and severe geometry make everything feel a bit too intellectually dressed up. Rogue planets move through a softer kind of dark, the dark between stars, where starlight is still present but distant, reduced to bright points in an immense sky. They are immersed in the hum of empty space, accompanied by ancient radiation, perhaps passing through thin streams of interstellar matter, but largely free of immediate glare. Stand, for a moment, in imagination on the surface of such a world. The ground under you might be ice-hard and silent, or rock brittle with cold, or perhaps a frozen crust over something warmer below. Above you, there's no sun, only a sky soaked in stars. Not one dazzling local star dominating the heavens, but thousands and thousands of remote lights, each sending its old delayed message across the void. The Milky Way might arch overhead with startling clarity, a river of white so vivid it hardly seems real. The constellations, if you could call them that from such a place, might shift completely depending on where in the galaxy the planet wandered. The sky would belong to distance itself, and yet the world might not be entirely dead. That is one of the most beautiful possibilities. A rogue planet does not need sunlight to possess internal heat. Radioactive decay in its core can still generate warmth. Residual heat from formation may linger. If the planet is massive enough, and if it carries a thick insulating atmosphere, especially one rich in hydrogen, it might retain more heat than you would expect. Some scientists have proposed that under the right conditions, even a planet adrift between stars could maintain liquid water beneath an icy shell, or perhaps even at the surface if the atmosphere trapped enough warmth. It sounds extravagant until you remember that space already contains black holes that whisper, dark matter that scaffolds galaxies, and dust clouds that manufacture suns. A hidden ocean on a starless planet is almost modest by comparison. This means life, at least in principle, might not be completely impossible on such a world. Not forests and birdsong and summer peaches, sadly, because the lighting would be dreadful. But microbial life in a subsurface ocean, perhaps nourished by geothermal activity, chemistry, and time? That idea remains one of the loveliest possibilities in astrobiology. A dark planet, drifting alone, carrying an ocean under ice, with no sunrise for billions of years, and yet still maintaining a secret interior sea. The universe cannot resist, making its most hopeful scenarios sound like whispered rumors. You can almost feel the strange tenderness of that image. A world exiled from the warmth of a star, and still refusing to become entirely inert. Still holding heat in its center. Still keeping water hidden under pressure and cold. Still preserving the possibility that chemistry might become something more. Solitude does not always mean lifelessness. Darkness does not always mean the end of activity. The hidden, once again, may be where the important things continue. Of course, rogue planets are difficult to detect. They do not shine like stars. They do not orbit a bright host that gives them away through regular dips in light. They move quietly. Astronomers often find them through gravitational microlensing, one of those wonderfully delicate methods that feels almost too subtle to work and then somehow does. If a rogue planet passes in front of a more distant star from our perspective, its gravity can briefly magnify the background starlight. The planet itself remains dark, but its gravity betrays it for a moment, much the way dark matter reveals its presence through influence rather than appearance. That parallel is pleasing. The universe keeps teaching the same lesson with different props. What cannot be seen directly may still announce itself through effect. Gravity becomes the whisper translator. A brief brightening of a distant star can reveal a wandering world between the stars, a silent body crossing the line of sight for no reason other than galactic chance. There may be many such worlds, perhaps astonishingly many. Some studies suggest rogue planets could be common, maybe even numerous enough to rival or exceed the number of stars in the galaxy, depending on what masses and formation histories you include. Imagine that for a moment. The Milky Way might not be only a city of suns and their obedient families. It may also be filled with untethered travelers, countless lonely-looking worlds moving through darkness without a local dawn. A second population of planets, quiet and mostly unseen, taking the long road. That abundance changes the feeling. A rogue planet is no longer just a tragic exception. It becomes part of a hidden pattern, an entire class of worlds you rarely hear about, because they're not lit for easy photography and they do not flatter our instincts about what a planetary system should look like. Yet there they are, perhaps by the billions, scattered through the galaxy like thoughts the universe never said out loud. And some may still carry moons. That detail makes everything even softer. A planet drifting alone through interstellar space, perhaps accompanied by one or more moons still bound to it by gravity. A tiny private system moving through the black. No star, but still relationship. Still orbit. Still a dance, however small. If the planet retained internal heat, tidal flexing from a moon could add even more energy to the interior, helping keep subsurface water liquid. You begin with a world flung into darkness and end with the possibility of an underground ocean quietly stirred by a moon that never left. The cosmos, for all its coldness, can be unexpectedly sentimental. You might wonder what time means on such a world. Day and night, as you know them, would lose their meaning. There might be rotation, yes, but without a nearby sun, turning would not bring dawn. There would be only phases of darkness, star-filled darkness, perhaps dim, clouded darkness if an atmosphere scattered distant light, perhaps auroral curtains if magnetic fields and charged particles interacted. Time would be kept by geology, by orbiting moons, by internal rhythms, by the slow cooling of the world itself. Human schedules would look especially ridiculous there, which is healthy. And maybe that is part of the charm. Rogue planets are cosmic reminders that not all worlds need to perform brightness to matter. Some do not orbit center stage. Some leave the system. Some travel without applause, carrying their mysteries inward. They belong to the same grand universe as nebulas and background radiation and black holes, but their majesty is quieter. They are not grand because they dominate. They are grand because they persist. So you hold the image a little longer. A dark sphere moving steadily through the interstellar cold. Ice on the outside, perhaps warmth within. No sonrisa, no sunset. Above it, the old light of distant stars. Around it, the silent depth between systems. Beneath its frozen shell, maybe an ocean, maybe chemistry, maybe the faintest beginning of life continuing where no one would have thought to look. A planet does not need a sun overhead to remain a world. Sometimes it only needs gravity, time, and a stubborn little core of heat. And in that deep silence, traveling through the galaxy without ceremony, the rogue planet becomes less a symbol of exile and more a portrait of endurance. A world that lost the light nearby, yet kept going anyway. That stubborn little core of heat inside a rogue planet. Keeping time without sunrise or sunset leads you into a stranger comfort still. Because the next mystery is not just that space is large or dark or full of hidden architecture. It is that time itself is not as rigid as it feels when you're waiting for a message, standing in a checkout line, or lying awake at 2:13 in the morning wondering why the brain suddenly thinks this is the right moment to revisit every awkward conversation since childhood. Time, on the scale of the universe, is not a single universal river flowing evenly for everyone, everywhere. It stretches, it contracts, it changes pace depending on speed and gravity. The cosmos, in other words, does not care at all about your watch. And somehow that is relaxing. You're raised to think of time as steady. 1 second here, 1 second there, a neat procession of equal little boxes marching past with bureaucratic confidence. Clocks seem to agree. Calendars line up. The world of ordinary life depends on that consistency. But relativity, one of the deepest discoveries in science, gently informs you that this familiar picture is only approximately true in the calm neighborhood of your daily experience. The deeper reality is stranger and much more elegant. Time is woven together with space, and the rate at which it passes is not fixed once and for all. That sounds abstract until you begin with something simple. Light always travels at the same speed in a vacuum. Not almost the same. Not the same if everyone promises to behave. The same no matter how fast the source is moving or how fast the observer is moving. This one fact forces everything else to become delightfully weird. If the speed of light stays constant, then space and time themselves must adjust to make that possible. So imagine a clock made of light. A beam bounces between two mirrors, up and down, each round trip marking a tick. In the clock's own rest frame, the light travels straight up and down. But if the clock is moving sideways, past you at very high speed, you would see the light follow a diagonal path, a longer zigzag. Since light must still move at the same speed, and the path is longer, the tick must take more time from your point of view. The moving clock runs slow. That is time dilation, one of the most poetic consequences of relativity. Motion changes time, not metaphorically, not emotionally, literally. A clock traveling at immense speed ticks more slowly relative to a clock at rest. A person moving very fast ages a little less than someone who remains behind. This effect is tiny at everyday speeds, which is probably for the best because family reunions are already complicated enough. But at speeds approaching that of light, the effect becomes dramatic. Minutes for one traveler can correspond to years for someone else. Time stops behaving like a universal background and becomes part of the journey itself. And it is not just speed. Gravity does something similar. Mass curves space-time, and in stronger gravity, time passes more slowly. This is not just black hole theater, though black holes do take it to the severest possible level. Even on Earth, clocks at higher altitude tick very slightly faster than clocks at sea level because they are a bit farther from Earth's center of gravity. The difference is tiny, but real. Your feet and your head are technically aging at slightly different rates, which is one more reason to be kind to your knees. This means time is not evenly laid across the universe like a fresh tablecloth. It drapes. It sags around massive objects. It varies with motion. Two observers following different paths through space and gravity can meet again and discover that different amounts of time have passed for each of them. The universe contains not one master clock, but many local experiences of duration, all woven into a larger geometry. That geometry is beautiful to imagine. You no longer picture space as an empty box and time as a separate ticking metronome. Instead, you picture a single fabric, space-time, with mass and energy shaping its curves. Planets orbit not because some invisible force reaches out with cords, but because they move through curved space-time in the natural paths available to them. Time, meanwhile, is part of that same fabric, bending and stretching with the rest. Suddenly, the cosmos feels less mechanical and more fluid. Think again of black holes from earlier, those severe, quiet wells where clocks disagree so dramatically. Near a black hole, gravity becomes so intense that time dilation grows extreme. A person far away and a person deep in that gravity would not share the same rate of time. It is as though the universe has many tempos playing at once, and gravity conducts them without ever bothering to explain the score. Closer to the mass, the tempo slows. Farther away, it quickens. No one is wrong. No one is holding the correct universal stopwatch. The structure itself has changed. Even without black holes, this dreamy weirdness appears all over space. Satellites orbiting Earth experience both motion-based and gravity-based time shifts. Their clocks do not match clocks on the ground unless those effects are carefully accounted for, which means one of the most advanced technological systems in modern life depends on acknowledging that relativity is not some decorative idea for physics lectures. It is built into reality so thoroughly that even navigation has to respect it. The universe will not simplify itself for convenience. It will, however, allow your map app to function if the engineers do their homework. And there is something deeply comforting in that. Reality is strange, but not chaotic. Time bends, yet the bending follows law. The universe is dreamlike without becoming random. You can let that settle in slowly. The same cosmos that hides dark matter in invisible halos and rogue planets in starless drift also softens the very thing you thought was most solid. Time becomes local. Duration becomes relative. The ordinary sentence, "what time," is it begins to sound faintly overconfident. The better question might be, for whom, where, and under what conditions of motion and gravity? There is a humility in that question that feels good before sleep. It loosens your grip on the hard little schedule boxes you carry around your mind. This happened too late. I should be further along by now. It has been too long. I am behind. The universe, meanwhile, is calmly curving time around stars and planets, letting clocks diverge by altitude, speed, and mass, entirely untroubled by your color-coded planner. Cosmic relativity does not solve your calendar, sadly, but it does remind you that the deep structure of reality is not built on hurry. Imagine traveling near the speed of light, just as a thought experiment. You board a ship. You accelerate for a long while until the stars ahead bunch and brighten, and the universe outside becomes distorted by your motion. Inside the ship, your heartbeat feels normal. Your coffee cools at an ordinary rate. Your thoughts arrive in the usual order. You never feel your own time slowing. That is the key. Time dilation is not experienced as weird from inside your own frame. You live normally inside your local flow. It is only when you compare across different journeys that the strangeness appears. That is so gentle, really. Each observer carries a valid present with them. The universe does not ask you to feel distorted from within. It only asks you to accept that your path is not the only path. Someone else, moving differently or sitting in a different gravitational field, may carry a different measure of elapsed time and still be equally real. That idea can soften more than physics. It can soften thought itself. Different clocks, different routes, different experiences of duration. The cosmos is built to permit multiple histories of time to coexist. There is also the strange concept of simultaneity, which relativity quietly dismantles. You assume events happening at the same time are simply happening at the same time, full stop. But for observers moving relative to each other, simultaneity can break apart. Two flashes that appear simultaneous to one observer may not be simultaneous to another. There is no single cosmic now slicing neatly across the whole universe. The present is not one shared universal sheet laid over everything at once. It depends on motion and frame. That can feel unsettling if you poke it too hard, but it can also feel wonderfully spacious. The universe does not demand one rigid answer to the question of now. Different observers carve reality into past, present, and future in ways shaped by their motion. The cosmos has room for that. It is not brittle. It is relational. And at larger scales, the history of the universe itself contains its own wild time story. Because light takes time to travel, because space expands, because gravity shapes how clocks run, looking outward is always partly looking backward. The delayed starlight from the beginning of this journey returns here with new depth. Not only do you see the past when you look far away, but the very meaning of elapsed time depends on the route through space-time. The sky is a layered archive of clocks that have not all agreed, and somehow the whole thing still forms a coherent universe. Maybe coherence is the most calming word here. Relativity does not destroy order. It deepens it. There is still causality, still law, still a grand consistency beneath the strange surface effects. Nothing with mass outruns light. Causes still precede effects within the structure space-time permits. The rules are subtle, but they hold. The world is not falling apart. It is simply more flexible than your instincts guessed. So you imagine a spectrum of clocks spread across the cosmos. One on Earth, one high above in orbit, one near a dense star, one gliding on a ship at extraordinary speed, one perhaps circling far from a black hole, while another hovers closer in the steep well of gravity. They do not all tick together. They are not supposed to. Each clock is keeping honest time for where it is and how it moves. Difference is not malfunction. Difference is built in. That feels worth carrying with you. Because maybe the universe has been trying very politely to cure you of the illusion that everything important must happen on one fixed schedule. Stars form slowly in dust clouds. Ancient radiation still hums from the early cosmos. Rogue planets travel without dawn. Black holes bend duration into solemn shapes. And time itself, the thing you thought you could trust to behave, turns out to be supple, local, and full of quiet nuance. So you let your mind rest inside that idea for a while. Somewhere far away, a clock runs differently. Somewhere deep in gravity, moments lengthen. Somewhere moving fast through the dark, a traveler keeps ordinary time inside extraordinary motion. The universe is not late. It is not early. It is simply vast enough for many tempos, all true in their own place. And here, in your small and perfectly valid corner of it, the minutes can finally loosen. You do not need to hold them so tightly. The cosmos has already shown you that time itself knows how to bend. That supple, local sense of time makes it easier to accept the next cosmic discomfort, which is that galaxies themselves do not always behave the way a tidy mind would prefer. You might think that once you zoom out to scales so large that whole islands of stars are involved, the universe would begin acting more dignified, more orderly, less like it is constantly sliding one mystery under the door and strolling away before questions can be asked. But galaxies, with all their grandeur, have a habit of moving in ways that suggest the cosmos is both lawful and slightly mischievous. They are beautiful first, of course. Spiral galaxies with arms curving outward like luminous weather systems. Elliptical galaxies glowing like ancient golden embers. Irregular galaxies looking as though someone nudged the blueprint halfway through and the universe simply shrugged and carried on. Each galaxy contains staggering numbers of stars, along with gas, dust, dark matter, star clusters, black holes, magnetic fields, and the leftovers of long histories of collision and growth. They are not simple objects. They are cities, ecosystems, archives, and storms all at once. And when you watch how they rotate, the trouble begins. You might remember the quiet oddness from earlier, when dark matter first stepped onto the stage without ever consenting to a proper photograph. If you look at a spiral galaxy, common sense whispers that the stars farther from the center should orbit more slowly. That is how it works in the solar system. Inner planets move faster. Outer planets move slower. The farther out you go, the weaker the pull from the central mass seems to become in a simple, familiar way. So, astronomers expected something similar for galaxies. But galaxies, being galaxies, refuse to cooperate. When scientists measured the rotation speeds of stars and gas in spiral galaxies, they found that far from the center, where the visible mass had thinned out, the outer regions were still moving surprisingly fast. The speeds did not drop off the way neat equations, based only on visible matter, would predict. Instead, the rotation curves flattened. Out there in the dim outskirts, where fewer stars shine and the brightness fades, the motion remained stubbornly high, as though the galaxy were carrying far more mass than its light admitted. This is one of the great moments where the universe seems to smile without showing teeth. Because the stars are not misbehaving randomly. They are behaving consistently in a way that exposes a deeper layer of structure. The apparent mismatch between visible matter and motion is not chaos. It is a clue, a repeated, graceful clue showing up across galaxy after galaxy, like a hidden signature written into the spinning of the night, that already makes the cosmos feel more mysterious than decorative. The glowing stars are not the whole story. The elegant spiral arms are only the visible lace on a much larger form. Galaxies are embedded in dark matter halos so immense that the bright disk you notice is just the lit center of a far grander, invisible arrangement. It is like discovering that a chandelier hangs not from a ceiling, but from an entire unseen cathedral above it. And the galaxies do not merely spin. They interact. You can picture two galaxies approaching each other over millions of years, though approach is such a humanly impatient word for something that unfolds on these scales. They drift, tug, distort. Tidal forces pull long streams of stars outward into arcs and tails. Gas clouds compress. Star formation flares in places. Eventually, the galaxies may merge, not in a sudden crash, but in a slow, majestic entanglement. Their shapes warp, their cores spiral around one another, and over time, a new, larger galaxy emerges from the dance. That dance is one reason galaxies can look so strange. Some carry long tidal tails like silk pulled loose in dark water. Some appear ring-shaped from collisions. Some seem lopsided, stretched, or bruised with star-forming regions where gas has been stirred. Beauty in astronomy is often evidence of past disruption. The universe decorates itself with aftermath. And then there are the giant galaxies that sit in the centers of clusters, swollen and ancient, as if they have spent eons quietly collecting smaller neighbors. These colossal ellipticals can be enormous, built through repeated mergers, layered histories folded into one broad golden glow. They feel less like individual objects and more like the settled capitals of galactic empires. Around them, clusters hold hundreds or thousands of galaxies together in shared gravity, moving through halos of hot gas and dark matter so vast that the whole scene begins to exceed ordinary imagination. Clusters are strange enough, but beyond clusters lie filaments, walls, voids, and a large-scale structure of the universe, an architecture so enormous it can make your mind go very still. Galaxies are not sprinkled through space like random glitter. On the largest scales, they form a cosmic web. Long filaments of matter stretch across hundreds of millions of light years, connecting dense nodes where clusters gather. Between them lie giant voids, enormous regions with relatively few galaxies, immense dark hollows in the grand distribution. It is as if the universe grew like frost on a window or foam settling into delicate branching patterns. Not uniform, not chaotic, but web-like. That web emerged over time from those tiny fluctuations in the early universe we touched earlier, slight density differences in the ancient glow that gravity slowly amplified. So the web is lawful, yes, but still uncanny. You look at maps of galaxy distributions and see something almost biological, almost organic, as though the cosmos has grown nerves or roots. It has not, of course. The universe is under no obligation to resemble living systems, and yet sometimes it lands alarmingly close to visual metaphors that make you wonder whether geometry itself dreams in similar shapes across different scales. Within this web are structures so large they begin to feel impolite. Galaxy superclusters, great walls, vast concentrations and arrangements of matter stretching across distances that make individual galaxies seem like dust motes. When astronomers identify one of these giant structures, it can provoke a very particular flavor of scientific excitement, the kind that says, well, that is unexpectedly enormous. There is a threshold where scale stops feeling majestic and starts feeling faintly suspicious, as though the universe has exceeded the dimensions your intuition filed as reasonable and is now waiting for you to catch up. The relaxing part is that your intuition is not expected to keep up. You are not built to feel at home with tens of millions of light years, much less hundreds of millions. You are built to locate the bathroom in the dark and decide whether fruit has gone bad by smell alone. The fact that cosmic structure overwhelms your ordinary sense of proportion is not a personal failure. It is simply evidence that reality is gloriously larger than the mind's default settings. And yet those settings can stretch. You begin to imagine a galaxy cluster as a floating city of cities, each galaxy itself full of stars and worlds, all held in a shared gravitational basin. Then you imagine that cluster as one bright, not in a filament connecting to other knots across the cosmic web. Then you imagine the voids between them, not empty in an absolute sense, but spacious, sparse, quiet beyond quiet. The universe alternates between gathering and opening, weaving bright tapestries and dark intervals, structure and spaciousness, density and hush. Even stranger, some galaxies appear to have formed surprisingly early in cosmic history, becoming massive and mature-looking at times when you might have expected the universe still to be arranging its furniture. That does not necessarily mean the models are wrong in some theatrical sense, but it does mean nature continues to challenge assumptions about timing, growth, and efficiency. The cosmos occasionally seems to look at theoretical expectations and say, yes, good draft, now watch this. There are galaxies with bars crossing their centers, funneling gas inward. Galaxies with active cores blazing because supermassive black holes are feeding. Galaxies that have effectively stopped forming stars and gone quiet. Galaxies that are starburst systems, turning gas into stars at furious rates for a while before settling down. Galaxies stripped of gas by cluster environments. Galaxies cannibalizing smaller companions. Galaxies wearing the evidence of old collisions like scars. No two have exactly the same history. They are not ornaments manufactured on a production line. They are biographies written in gravity. That phrase matters. Galaxies are biographies written in gravity. Once you see them that way, their oddness becomes gentler. The strange rotation curves are not disobedience. The tidal tails are not damage alone. The giant structures are not mistakes. They are chapters. A galaxy carries memory in its shape, motion, chemistry, and surroundings. Stars of different ages tell different parts of the story. Gas clouds reveal what remains possible. Halo stars and globular clusters preserve older eras. The central black hole holds its own quiet role in the narrative. Even the missing mass, the invisible dark matter halo, becomes part of the biography, the hidden parenthesis around everything visible. And this hidden visible duet keeps repeating. The bright disk turns because unseen mass surrounds it. The cosmic web shines with galaxies while vast, dark intervals give it form. You keep meeting the same deep principle from different angles. What you can see is real. What you cannot see may be even more decisive. The universe has no interest in being merely obvious. That may be why giant cosmic structures feel so haunting and so comforting at once. They suggest that order exists, but not always in the local, tidy, human sense. The order is statistical, emergent, stretched over distances that make your own scale nearly disappear. It does not present itself with labels and arrows. It grows from gravity, expansion, dark matter, time, and initial fluctuations so faint they once hid in a whisper of background radiation. Out of that, galaxies gathered. Out of galaxies, clusters. Out of clusters, filaments and walls. Grandeur by accumulation. Pattern by patience. You can rest with that. You do not have to force the cosmos into a simple picture to admire it. Galaxies that should, by your first instincts, behave more neatly instead reveal a deeper elegance. They spin too fast, merge too beautifully, gather into networks too vast, and persist as luminous evidence that the universe is both more structured and more mysterious than a quick glance allows. So you hold the image now of a spiral galaxy turning in the dark, its outer stars moving with that impossible steadiness, its bright arms only the visible fraction of a larger invisible halo. Around it lie other galaxies, then clusters, then filaments, then enormous voids, the whole web stretching farther than your mind can comfortably frame. And rather than resisting that scale, you let it wash over you. Suspicion softens into awe. The cosmos need not behave simply to behave beautifully. It only needs to keep turning, keep gathering, keep revealing slowly, quietly, that its deepest order was never designed to fit inside a small, impatient brain all at once. That slow revealing brings you to one of the most intimate mysteries of all, because by now the question is no longer only what is out there, but whether anyone else has ever looked back. After old light, invisible mass, black holes with their severe manners, the hum of ancient radiation, the dust-hidden nurseries, the starless rogue worlds, the flexible clocks, and the galaxies behaving just suspiciously enough to keep everyone humble, a very human thought rises almost automatically. In a universe this large, this old, this patient, are you really alone? It is one of the gentlest, unsettling questions ever asked. Not because it arrives with panic, but because it arrives with scale. There are hundreds of billions of stars in the Milky Way alone. Around many of those stars are planets. Some systems hold rocky worlds. Some of those worlds may orbit at distances where temperatures could allow liquid water. Some may have atmospheres. Some may have chemistry rich enough to do more than simply sit there looking mineral. And beyond the Milky Way are more galaxies than your mind enjoys counting, each with more stars, more planets, more chances. The numbers open like a door and keep opening. So your first instinct is often that life elsewhere must be common. How could not be? The universe seems almost offensively productive. It makes stars and dusty clouds. It scatters rogue planets into the dark. It wraps galaxies in invisible halos as if abundance itself were a habit. Why would biology happen only once? And yet the sky remains strangely quiet. This is the heart of what is often called the Fermi paradox, though paradox makes it sound more formal than it feels lying there in the dark. The basic puzzle is simple enough to fit into a whisper. If intelligent life is common, where is everybody? Where are the signals, the probes, the unmistakable signs of technology, the evidence that someone else has crossed the long bridge from chemistry to consciousness, and then from consciousness to engineering? The galaxy is old, much older than human civilization. In principle, plenty of time has passed for other societies to arise, spread, transmit, build, leave traces. And still, the night offers no obvious reply. That silence can feel eerie if you lean into it too suddenly, but it can also feel tender, because silence is not the same as emptiness, just as dark matter was not the same as nothing, and the cosmic microwave background was not the same as true stillness. Silence can mean distance, rarity, timing, a mismatch of methods. 100 civilizations listening on channels no one else uses. A universe full of life that simply does not arrange itself into easy introductions. You begin with the possibility that life itself may indeed be common, while intelligence capable of building radio telescopes and mildly regrettable social media platforms may be rarer. Microbial life might emerge relatively easily where conditions permit, while complex multicellular life could require a long list of stable circumstances: time, chemistry, energy, environmental balance, planetary protection, luck. Intelligence might be rarer still, and technological civilization, that noisy little flare humans are currently performing, may be the rarest stage of all. The path from ocean chemistry to someone arguing online about batteries may be longer and stranger than optimism first assumes. That possibility is oddly calming. It means the universe may not be empty of life, only quiet in the specific way you are currently trying to hear it. There's also the matter of timescales, which by now you know the cosmos enjoys using as a practical joke against intuition. Human radio transmissions have been leaking into space for only a little over a century. That is nothing. A blink, a dust mote of time. The sphere of human-made radio signals expanding outward from Earth is still tiny compared with the galaxy. It has not reached many stars, and even where it has, the signals grow weaker with distance, dissolving into background noise. You are, in cosmic terms, not broadcasting from a grand stage. You are whispering from one room in an enormous mansion and then wondering why no one on the far side has complimented your acoustics. Maybe other civilizations also flare briefly. Maybe they discover radio, use it for a while, then move on to quieter technologies. Maybe there are countless windows of detectability opening and closing across the galaxy, rarely overlapping. Two civilizations could exist in the same galaxy and still miss each other by 1,000,000 years, which sounds absurd until you remember the age of starlight and the patience of nebulae. Time is vast enough to make missed encounters normal. Distance does its part too. Even light takes years to cross between nearby stars, tens of thousands of years to cross large portions of the galaxy. A conversation at that scale is less like texting and more like leaving beautifully composed voice notes for descendants not yet born. You send a message. Centuries pass. A reply returns long after every original sender has become dust and memory. Interstellar chat is not impossible. It is just catastrophically bad for momentum. That makes the quiet more understandable. Not disappointing exactly, just structurally built in. Still, humans listen. Radio telescopes scan for patterns that nature is unlikely to produce by accident. Narrowband signals, repeated transmissions, strange regularities. Astronomers study exoplanet atmospheres, hoping to detect gases that might hint at biology, oxygen perhaps, methane in suspicious combinations, chemical imbalances that whisper of metabolism. Researchers imagine technosignatures too, signs not of life in general, but of technology specifically. Artificial light, unusual heat patterns, industrial chemicals, megastructures dimming starlight in ways no natural object quite would. The search itself is lovely. It is patient without being passive. A species sitting on one small planet, turning instruments toward the dark, asking carefully whether the silence is complete. And the silence, so far, remains incomplete in an interesting way. There have been intriguing signals, false alarms, strange detections later explained or never fully repeated. Pulsars were once so surprising that, jokingly, they were nicknamed after little green men before their natural explanation became clear. Fast radio bursts appeared as one more mysterious phenomenon needing careful work rather than immediate alien fan fiction. Though humanity, of course, produced the fan fiction anyway, because restraint is not our defining trait. The lesson from these episodes is not that the search is foolish, but that the universe contains plenty of natural wonders capable of looking briefly uncanny. That, too, is comforting. You do not need aliens for the cosmos to remain astonishing. It already has rogue planets with hidden oceans, galaxies wrapped in unseen mass, black holes that make time misbehave, and light from the beginning still humming through space. The search for company does not arise from boredom. It arises from abundance. And maybe that is why the quiet feels poignant rather than crushing. You are listening in a universe already full of mystery. The absence of a clear answer does not strip the sky of meaning. It gives the sky another layer. Some people imagine the silence means intelligent civilizations destroy themselves quickly. That is possible, though not cheerful. Others imagine that advanced civilizations become less visible over time, more efficient, quieter, harder to detect. Some imagine they are rare and widely separated. Some think life may be common in oceans under ice, on rogue planets, on moons with hidden seas, in forms that never produce radio at all. Some wonder whether the galaxy is full of biology and nearly empty of engineering. Some suggest that intelligence itself may not be evolution's inevitable destination, merely one quirky branch among many. All of these possibilities share one soft truth. The universe is under no obligation to arrange companionship in the form most flattering to human expectations. And human expectations, if you're honest, are a little theatrical. You imagine signals arriving on cue, visitors choosing obvious landmarks, civilizations eager to announce themselves with the subtlety of a marching band. But if another intelligence exists, it may be alien in the deepest sense. Different senses, different timescales, different habitats, different priorities. It may live beneath kilometers of ice, or in thick clouds, or around dim stars, or on worlds where dawn looks nothing like yours. It may never think of radio. It may never care to build machines. It may be ancient and quiet, or new and not yet listening, or widespread and invisible to methods you happen to favor. The hush of the universe may not be refusal. It may simply be difference. That thought can ease the loneliness, because even on Earth, understanding across distance takes work. Across species, across languages, across cultures, across moods, across one badly phrased text message that accidentally starts a miniature Cold War. Communication is never automatic. Why would the galaxy be easier? So you let the question soften. Not where is everybody with impatient tapping fingers, but what forms can presence take in a universe this varied? Maybe company is microbial, hidden in an ocean under ice. Maybe it glows faintly in an atmosphere far away. Maybe it existed millions of years ago around a star now long changed. Maybe it is still to come. Maybe it is rare enough that your own existence matters more, not less. Maybe the silence is temporary. Maybe it is deep. Either way, listening changes you. It makes you humbler. Kinda, perhaps, more aware that consciousness on a small world is not trivial. If intelligent life is rare, then what has emerged here is precious beyond habit. If intelligent life is common, then you are part of a much wider living cosmos and still precious in your own local way. The search leads back to care either way. Either you are one candle among many, or one of very few. In both cases, the flame matters, and the silence itself has texture. It is not a blank wall. It is a star-filled interval, a pause full of old light and ancient background glow, full of galaxies turning too fast and dust clouds assembling future suns. It is the same layered hush you've been moving through all night. The question of company does not interrupt that hush. It belongs inside it. So you picture the Milky Way overhead, not as a decorative stripe, but as a vast population of worlds. Some hot, Some frozen, some shattered, some hidden under cloud, some orbiting red dwarfs in close, quick paths, some wandering alone like the rogue planets you met earlier, carrying secret heat through the dark. Somewhere in that spread, chemistry may have crossed the threshold into life more than once. Somewhere, perhaps, life has looked upward and asked the same question. And maybe on some distant night under another sky, someone has listened to silence and found it beautiful too. That possibility is enough. Not proof, not certainty, just enough. Enough to make the quiet feel inhabited by potential. Enough to let wonder remain gentle. Enough to remind you that the absence of an answer is not the absence of meaning. So you keep listening, not with urgency, but with affection. The universe may be hushed, but it is not cold in the emotional sense. It is simply large, old, and very, very subtle. If there is company out there, it may take a long time to find. If there is not, then your own awareness becomes one of the rarest and most delicate things the cosmos has made. Either way, the stars do not look emptier. They look deeper, and the silence above you, far from being a void, becomes something almost like a held breath. And that held breath carries you to the last and widest mystery of all, because sooner or later every thought about old starlight, invisible dark matter, black holes with their impeccable boundaries, rogue planets traveling without sunrise, and the hush of possible company leads to the same enormous question. What is all this inside of, if anything? Does space go on forever? Does it curve back on itself? Does it have an edge somewhere, some ultimate wall where the universe politely ends and reality puts up a sign saying, "Lovely having you. No further corridors tonight"? It is one of the most calming questions precisely because it refuses to become ordinary. You're used to objects having edges. Tables end, roads end, rooms end. Human intuition expects boundaries. If there is a map, where is the border? These instincts are excellent for cupboards and neighborhoods and deciding whether you have reached the back of the freezer. They are less useful when applied to the totality of cosmic space, because the universe may not have an edge in the way your instincts demand. One possibility is that space is infinite, not merely very big, but actually unending. Go far enough in any direction and there is still more space, more darkness, more distant matter, with no final wall and no outer boundary waiting to be touched. The mind hears that and immediately tries to picture it, fails, and becomes quietly offended. Infinity does that. Another possibility is subtler and somehow even more soothing. Space could be finite but unbounded. Think of the two-dimensional surface of a sphere. It has finite area, yet if you travel along it, you do not encounter an edge. You can keep going and eventually return to where you started without ever falling off. In a similar way, three-dimensional space could, in principle, have a shape that is finite yet edgeless. That means asking where the edge is maybe a little like asking where the edge of Earth's surface is if you forget about coastlines and think only about geometry. There need not be an edge. There might only be continuation. On the largest scales, space can be flat or curved, and current evidence suggests the universe is very close to flat. Exquisitely close. That does not completely settle whether it is infinite, because a flat universe can still have more exotic global shapes that wrap around. Reality, as usual, declines to become too easy just because you are tired. Still, even the observable universe is not the whole universe. The observable universe is simply the portion from which light has had time to reach us. It is enormous beyond comfort, but it may be only a region within a much larger whole, perhaps far larger, perhaps infinitely larger. There are places from which light has not had time to arrive yet, not because they do not exist, but because the cosmic story has not carried their signals here. Just as Sirius sends old light from years ago, there may be realms so distant that no light from them has ever reached Earth at all. That alone is enough to make your thoughts go very quiet, because it means there are limits not necessarily to reality, but to what can ever be seen from one small place within it. Horizons are built into the cosmos. Not walls, but boundaries of access. You can look out across space and still not see all of it. Not because the rest is hidden maliciously, but because light needs time and space itself expands. Expansion complicates everything beautifully. Space itself is stretching. Galaxies on the largest scales recede from one another because the space between them expands. This is one of those facts that never stops feeling slightly illegal. The fabric itself grows. And because that expansion appears to be accelerating, some distant regions are effectively carried away so quickly that light they emit now may never reach us in the future. So when you ask whether space has an end, the answer becomes beautifully slippery. There may be no edge. There may be a shape. There may be far more beyond what can be seen. And all of that sits inside one staggering truth. The universe does not need to finish in a way your mind can walk up to and tap with its knuckles. That refusal is not cruel. It is peaceful. You do not need a final wall for reality to be real. You do not need a ceiling over the stars. The cosmos can be whole without offering a neat perimeter. In fact, that may be why the night keeps pulling thought outward. Every answer expands a room. Every solved mystery opens into something wider. Maybe that is the deepest callback of all. The stars were already old when their light reached you. Dark matter mattered without shining. Black holes hid their centers behind geometry. Nebulas built suns inside dust. Rogue planets kept warmth in darkness. Time bent. Galaxies spun with more gravity than they showed. The universe stayed quiet about company. At every stage, the lesson was the same. Reality is larger than first appearances. So of course the final question would refuse to fit inside a tidy box. And there's a softer version of the edge question too. Not where does space end, but does it need to? Human thought loves completion. Final pages, last doors, concluding music. But nature often prefers gradients. Coastlines blur. Atmospheres thin into space. Dawn arrives by degrees, not by a switch being flipped. Why should the universe itself end with a crisp border if so much of reality prefers transitions? Perhaps the truest image is not of a wall, but of unfolding. Space extending beyond what you can see. Perhaps forever. Perhaps wrapping in some grand apology. Perhaps stretching into regions your light will never reach. Not a final edge, but a continual opening. There are even ideas that our observable patch may be only one region within something vastly bigger. You do not have to marry every speculative model to appreciate the emotional effect. The visible universe may be one lit window in a structure much larger than the floor plan you currently possess. You are inside one knowable room of a house that may continue beyond sight. And strangely, that can feel like home rather than exile. Because mystery on this scale becomes less about what you cannot master and more about what you are allowed to belong to. You do not have to reach the edge to live inside the grandeur. You already do. You are made of recycled stardust from nebular nurseries. You live under ancient light. Your clocks obey the same relativity that shapes black holes. Your galaxy turns within invisible scaffolding. Your world floats inside an observable horizon that itself may be only a local chapter. The universe is meaningful not because you can find its boundary, but because it exceeds you and still includes you. So the last image of tonight becomes very simple. You imagine moving outward, past moonlight delayed by a second, past sunlight delayed by minutes, past Sirius and its old postcard, past the dust clouds where stars are still assembling, past the rogue worlds and the galactic web, farther than any ship, farther than any signal, to the farthest reach of what can be seen, and then farther still in thought, beyond the observable horizon, into more continuation, more possibility, more soft, unanswered room. No wall rises there, no cosmic fence, just the peaceful fact that reality may continue beyond every last thing you can picture. And because this is the final stretch, The pace can ease now, the words can loosen, and the images can rest rather than insist. The universe does not need to resolve into a sharp answer tonight. It can remain wide. It can remain unfinished in your mind. It can remain a patient, dark openness full of old light, hidden mass, quiet clocks, and distant company, perhaps listening somewhere under another sky. So let the stars soften behind your eyelids now. Let the galaxies stop turning quite so clearly. Let the black holes keep their beautiful silence. Let the rogue planets travel on, carrying their secret heat. Let the ancient background whisper settle like the faintest warmth in a vast room. Let the question of edges loosen until it no longer feels like a problem to solve, only a space to rest beside. Nothing is rushing you toward an answer. The universe can go on being immense without asking anything more from you tonight. It can curve or stretch or unfold beyond every final thought and still hold you gently on one small world under one small patch of sky. The mystery does not press. It cradles. It invites your mind to unclench, to stop measuring, to stop reaching for the border, and to be soothed instead by continuation itself. There is more beyond what you know, more beyond what you can see, more beyond the last clear image, and that is all right. So the night grows quieter now, and wider, and softer around the edges. The facts lose none of their wonder, only their sharpness. They settle like dust in low light, like breath on cool glass, like the last faint hum in a house after everyone has gone still. Space does not end where your understanding ends. It simply keeps being space, serene and patient, and far beyond the need to explain itself all at once. You can rest inside that. You can let the unanswered parts remain unanswered. You can let the horizon stay where it is. And somewhere beyond every visible star, beyond every measured filament of galaxies, beyond every old signal still on its way, the universe continues in its own calm manner, not hurrying, not stopping, just opening and opening and opening, until even the idea of an edge becomes too hard and too unnecessary to hold. So your thoughts grow quieter with it. Your breathing steadies. The room feels a little softer. The sky, whether seen or only remembered, becomes a dark, gentle canopy with no final seam. And in that vastness, you are not lost. You are simply small, warm, and safely here, while the cosmos goes on being wonderfully, peacefully, impossibly wide.